All right, but what does that actually mean? We calculated the second derivative of the function. Well, the first derivative is telling us the rate of change in the function f. The second derivative is the derivative of the first derivative. Second derivative tells us the rate of change in f prime of x. So I can still say things like f double prime of x is negative when f prime of x has negative slope. F double prime of x is positive when f prime of x has positive slope. And I can check that on the picture too, right? For all the values of x where my green curve is negative, then my parabola in pink has negative slope. Whenever my f double prime in green is positive, my f prime in pink has a positive slope. Okay. Well, in terms of position, right, to go back to the physics example, then derivative of the position was my velocity function. That's what I've used before. What's the rate of change of the velocity function? Well, probably the most familiar thing would be acceleration. So maybe the velocity of my object is not steady over time. Maybe it is speeding up. I can measure that using the second derivative. Now, for functions representing other things, my idea about acceleration might not be the most technically accurate, but you should still be thinking about this as how much does the rate of change over time, right? My function is steep or shallow. It is increasing or decreasing. But those properties are not the same for all values of x. And I would like to measure how quickly that slope is changing as x moves along its axis.